Thank you for being here. Welcome to my talk, Getting Out of Quicksand with DevOps. For asking questions, I ask you to join Slido. And yeah, we can have some discussions later in the speaker's corner. So it's always difficult to be the first one after lunch break. So let's start with a small survey. This may not seem related, but if I do not forget about it, I'll come back to it, and actually it is related. So, so who of you just had lunch at the food court? Okay, that's almost everyone. Who had something small to eat? Who tried to max the voucher and get every single drop out of it? Yeah, okay, that's all of you. And so what happened when everyone rushed to the shops in the food court at 1 p.m.? Sorry, say again? Bottleneck, yeah, someone said bottleneck. So people were queuing, right? And it took most likely longer than you expected. But we will come back to that. So how did I end up here? I already said it in the introduction. My name is Pickl. I'm from Vienna. Since last year, I'm a technical project manager at Elektrobit, which is an automotive software supplier. And before that, I was CTO at a medium-sized company, but also a process manager at the Austrian parcel service. So I guess they also deal with continuous delivery. So I sometimes say that I've been in the continuous delivery business for some years. I have a background in IT and business, and CI/CD and DevOps is really the sweet spot for me. So I really love how the things that I learned in my production management and operation research courses during that I had when I studied business administrations are nowadays applied in the IT domain. And I also studied computer science, so I really like how these two things somehow fit together, and not only in my head, but also in the industry. Last but not least, I'm here to learn. Which means that I'm looking forward to your questions, to your remarks, and also to the discussions afterwards, especially if your opinions and experience differ. I think that's the most interesting one. So in September last year, I was speaking at DevOps Days in Cairo, and Andrew Schaffer showed this slide during his keynote, and it says, "I don't have time to learn new things because I'm too busy getting things done." And he quotes here the least productive person in the world. During that time, I was also finalizing this talk, and this quote really resonated with me. As at the same time, I was reading Tom DeMarco's book Slack, which also states that we are all too busy. And this is not only killing our efficiency, but also our effectiveness. So being effective is about doing the right things, while being efficient is about doing the things in the right manner. So you are efficient when you do something with minimum waste. You are effective when you're doing the right something. And it's possible to be one without the other. It's also possible to be both, but it's also possible to be neither. So for example, if you have a flat tire, your car breaks down, and you start cleaning your car or you change the wrong tire, you could be very efficient at this task, but you're definitely not effective in fixing your car. On the other hand, if you change the right tire, but it takes you like 2 hours because you don't know exactly how it's working, and you need multiple attempts to do it, you are still effective, but you're not very efficient. So we want to be both, but often we are neither. In his book, DeMarco also cites evolutionary biologist Ronald Fisher with Fisher's fundamental theorem. And it says that the more highly adapted, that is efficient, an organism becomes, the less adaptable it is to any new change. So we really need to find the right balance and not over-optimize. However, in my career, I found myself in situations very similar to the following one multiple times. So let's imagine I'm working part of a 3-person DevOps team, and there's one guy working like 100% of their usual workload, and there's this one guy, maybe a more senior person, working 130% of the usual workload. That's most likely the one with the most experience. They're skipping the lunch breaks or having lunch at their desk, working on weekends, sometimes being the bottleneck and having their hair on fire. And maybe there's one more person, maybe a more junior one, which has some slack, but no one of the other two has time to show them new stuff, or they are holding on to their dear tasks. So we experience an overload situation, and we are showing symptoms of overload. For example, decreased team morale, we're working long hours, or working when sick, more frequent illnesses, unhealthy tasks, task queues, imbalanced metrics, and so far and so forth. And then something interesting happens. What happens is that the following discussions are getting more and more frequent. So we use different cat pics on our Slack, but this is more or less a screenshot. So a colleague says something like, we really need to fix the XYZ hell, whatever that is. But this will take some time. And I, as a technical project manager, for example, I asked him, okay, so how long does it take? And I expect something to be like a week or a month or I don't know, a year. And they say something quite surprising. They say, it will take 2 to 3 days. And I'm like, what are we discussing here? So this 2 to 3 days, that's actually nothing. We should really do it. And but it doesn't happen. And it hurts again and again. For example, we really need to use a static code analyzer, improve the deployment pipeline, introduce a better debugger, and things like that. And most of these tasks are like 2 to 3 days at least to come up with a prototype, but it never happened. And I feel like this. So no thanks, I'm too busy. And I know that there's a better way of doing stuff. So I've talked with friends about it. I've seen it at conferences like DevOps Pro here in Vilnius, but we're just too busy. So who of you can relate to that? Okay, I see quite a number of hands. So I go to my manager and ask him or her for support in DevOps, in testing, or in the testing domain. And he or she says something like that. Yeah, I don't know if we really should look for support in this area. Maybe you can just do some redistribution of work so everyone is working like 100%. And it will certainly take time to find someone. And I'm not even sure whether we would be able to utilize that person up to 100%, because if all of you redistribute your task, you would be working 100%, and so there would be only 20% left for them. So the manager has a better idea. I'll talk to my colleague, like another manager, and there's a guy in another team. He's working on like 4 projects, or a girl, whatever, or a woman or man, and they work on 4 different projects, but or 5, but the 5th one just got stalled and it's on hold. And they have like this 20% that you need, and this will work out nicely. And I'm like, no, this is never going to work, because individual knowledge workers are not really exchangeable. So I cannot easily replace my colleague or do the work that they do. And actually, you don't want to do that anyway, because utilization is not a good proxy for productivity. And the manager's like, what? What do you want from me? And I'm like, yeah, maybe we should talk about queuing theory. So when I was preparing for this talk, I remembered that queuing theory and operations research is very interesting, but it is also quite hard to understand in the details. So there are different types of queues and models, but let's look at the simplest case. So when looking at the GG1 single server, at the GG1 queue, you have a single server, and the inter-arrival times have a general, meaning arbitrary distribution, and the service time have also a different general distribution. So for example, you could imagine a cashier with customers coming in at different times intervals with different numbers of articles in their shopping basket. Just think about the food cart right there. So for example, on a normal day, one of these cashiers or staff member in the food court, they would on average handle, I don't know, 30 people an hour or 20 people an hour. But that's on average. So what happens if you come in at 1 o'clock in a bulk, and now you're not only ordering the standard meals, but you really want to max out your vouchers because you got the 10 euro voucher and you want to really max out, and you order a lot of different stuff. So they try to keep variability very low by offering standard meals and standard options. And then you're just like, yeah, okay, I'll have my 10 euros, so I'm getting this and that. So actually what happens is that not only the variability in the arrival time is way off because everyone is coming at once, but also the service time of this individual server or the cashier increases because everyone is having a different wishes, or at least do not behave as normal. So what happens is that queues occur. So the lead time of a system is heavily influenced by the service time, the utilization of the actor, and also the variation of the task at hand, and also the inter-arrival variation. And that's what the Kingman equation tells us. So if we assume that the same is true for software development, that this is a process with high variability and with a decent amount of task and inter-arrival variability, then what happens is that the wait time is related to this is the capacity used. So the wait time is related to the percentage of time busy by the percentage of time idle. So if a resource is 50% busy, then it's 50% idle. The wait time is then 50% divided by 50%, and it also gets multiplied by the service time and this variability term here. And this works very nicely if variability is very low, then this is more or less 0. So you do not have any wait times as long as your capacity as long as you're not working over capacity. With 90% utilization, so with 50% utilization and some task variability, let's say this term is 1, you would have like a wait time of 1 unit of time. With 90% utilization, you see that things heavily escalate. So your wait time would be 9 times higher than with 50%. And so depending on this term, this curve gets steeper the higher the variability, and gets flatter the lower the variability. So if you do not have any variability in the system, and for example your arrival time and task time are the arrival times are evenly distributed, and you do not have any variability in the serving time, then you would not have any waiting time at the food court. So there's an inherent conflict between service quality and capacity management. They cannot put 70 people right there just because you are coming out of this conference. But yeah, and the things heavily deteriorate at starting from 70%. So it's also bad here, but this escalates quickly. A similar idea is also Little's law. I really like these nice screens because then everything you can still read my small print here, which tells us that there's a relationship between the average work in progress and the average throughput. So you can calculate the average lead time. That's important. It's an average by dividing the average work in progress and the average throughput. There are some important assumptions to that, and I put a nice presentation from Daniel Vacanti in my references that you may or should look at if you're interested. So the important takeaway is The first one is that queuing theory is difficult, and if you're interested, have a more detailed look. But the important takeaway for today is that you should focus on throughput rather than utilization. If you reach high utilization levels, like here, all your work is just piling up, and everyone gets very nervous, and they are calling for status meetings, which adds additional work, and so this escalates quickly. And then you reach a state that one of my colleagues in Vienna in a GitOps presentation at the Vienna DevOps security meetup referred to as Quicksand. It was Mario Kleinsasser. So it feels like Quicksand. The more you fight it, the more it pulls you in. Each time you try to put your leg out, it sucks you in again. But don't panic. So who of you feels like this at least sometimes, having high workload and not finishing anything? Okay, that's quite a few. So I really like this metaphor, and I Googled how to get out of Quicksand, and I was not disappointed. So I Googled this, so do not rely on it, but I really like the solution. So they say that you have to make yourself as light as possible, toss your bag, jacket, and shoes. And for me, that could also mean that you have, for example, reduce your work in progress. You should try to take a few steps backwards, for example, to analyze the situation. Keep your arms up and out of the quicksand. So make sure that you're still able to act. Try to reach for a branch or a person's hand to pull yourself out, but make sure that you don't pull them in. Take deep breaths, move slowly and deliberately. Yeah, that's it. So I go to my manager again and I tell him, you know, what we need is more people. And all of them should only be utilized by 80%. So that they can invest roughly a day per week to spur innovation, rethink what they're doing, practice new ways, master new skills, and improve efficiency. Because that's how it is or has been done at 3M. They had like this 15% time, and Google with 20% time. And what I really liked is at Google, they talk about this in this site reliability engineering workbook. The number 2 site reliability engineer principle is SREs must have time to make tomorrow better than today. And that's something to think about. Do you have the time to make tomorrow better than today? Maybe not. So after all this research and listing all the pros, I've persuaded my manager, but it's too late. What actually happened is that we got even more to do, and we spent considerable time interviewing people. It was quite unsure whether we would even find someone. So that the colleague, you know, the one with the hair on fire, could not bear it anymore and just quit. So now me and the other team member are also under heavy pressure. And people under time pressure don't think faster. But at least we found a very skilled professional who starts today. Could be you. And given that you've just joined the team, you usually cannot jump right in and you have some slack, at least in the beginning. So congratulations, you just joined the team in an existential crisis. But that's not necessarily a bad thing. In the A Seat at the Table book from Mark Schwartz, he writes that transformational projects occur when the amount of debt has become too much to bear. So often organizations need to experience, so organizations and also teams, need to experience an existential crisis before they really take continuous improvement seriously. And the reason for that is, or I think that's the reason for that, that a 10% change, for example, working overtime, is not enough anymore. You need something like a 50% change. You have 50% plus improvement is needed. So you need like an engineering solution. So if you can establish, and we already heard that today, but I repeat it again, a sense of urgency, so we have to change how we work. You work in a safe environment for failure, so things that were already late will shift because, for example, your colleague quit, but we really have to try something new. And on top of that, have the courage to question the status quo, which is easier if you're new to a project or to a company then crisis could be chances and opportunities to change things. I have one example, and I'm getting a little ahead of myself. So 3 years ago, I already told you I was CTO of a medium-sized company, and I supported our ops team and asked how we deploy our iOS apps. So they told me, for each of the 5 variants of the app, do the following. Check out the code on the local PC, make sure that you have the right Xcode version installed, do these 3 manual changes, select the right signing certificates, whatever that is, compile, upload to the App Store, enter and update all the relevant metadata, and then wait for Apple to review the software. So this takes approximately 1 day for all the 5 variants of the same app. And then I asked them, but what if like the developer or the tester or the project manager or customer or whoever finds an error in the application? Then yeah, you know, they told me we have to start over. And this is so painful that we release very seldom. And we asked the development team for less releases, which are beta tested. And I was like, yeah, you know, sorry, I'm not going to do it that way. It is 2015, at least back then, and there has to be a better way to do that. Maybe what was a good solution in the past is not today. So let's check. So I was being fortunate. 1 year earlier, Fastlane. Does anyone know Fastlane? Yay. Fastlane was released, which among others, it's doing a lot of stuff now, but which among others helps to automate the release process of apps. So we set up Fastlane with Jenkins in a way that by clicking a button, and that's something that the project manager or the tester could do, everything happened automatically. You just had to wait for 20 minutes. This took us roughly a week to get the first version up and running. And of course there was some tweaking required, but ever since, releasing iOS and then also Android apps, so this was the cool part, was a non-event. And we did it more frequently with the push of a button. So it really takes someone like you who questions the status quo. But where to start? So I think the first thing you should do is quantify the work. So what I like to do is something called activity accounting. So you can do this based on your timesheets or look at your taskboard. So what you do is you allocate costs to the activities the team is performing to uncover non-value work. But you should not only watch out, at least that's my opinion, for these categories. For example, new work, unplanned work, remediating security issues, customer support work, and so far and so forth. I think it's also interesting to have a look what's not happening. For example, are you releasing very often? Are you writing documentation? Do you have retrospectives? And so far and so forth. What you could also see is that if people have a lot of entries on their timesheets, then maybe they are doing multitasking because they're waiting for feedback, the build times are too long, or other people are not available. What I also like to do, and that's a side note, is make the things that your team is currently working on visible. So in the last company, we put a big monitor in front of our desks with our Kanban board, and everyone could see what we were currently working on. This reduced the number of interruptions and also helped to show that we had a lot of things to do. And if priorities differed, then people knew whom to talk to before bugging us. So this is from the Accelerate 2018 report. And what they do here is they have, for example, a low group, and they just spend 30% of their time on new work. And the elite group, they spend 50% of their time in new work. And for example, the low group, they work 35% on working on defects and customer support work, whereas the lead group only does it for 15% of the time. So it could be that in the low group, for example, there's a quality issue, or at least a documentation issue. Okay, so you know what you're spending your time on, and you should set goals based on benchmarks. But what takes so long? And there is a saying that what gets measured gets managed. So I think you should measure flow time, that is lead time and cycle time for the features you deliver. And also have a look at how long does an item spend waiting in testing on the build server between handoffs or waiting to be released. I think you should also measure the frequency of deployments and your mean time to restore services. And of course, there are additional measures that you could take into account, like, I don't know, bug lead time or code lead time and patch lead time and change success rate. But what I also think is that it's important to get a rough indication and order of magnitude first, rather than trying to measure it with a stopwatch. What's also important is that work in progress is the biggest deterrent to flow. It's a leading indicator, so the more work in progress you have in the pipeline, the longer things tend to take to complete, at least on average. Knowing that, you could have a look at aging reports, so look at the tickets, for example, that did not move or change their status for 30 days, and also have a look at your demand ticket in and outflow. On the other hand, we want to increase throughput. So what is the biggest bottleneck? Can we fix it? Can we bring the pain forward? So really ask why and investigate the root causes. Sometimes the fixes are quite easy once you know the problem. One example. I once worked in a project where the full cycle of building and testing took 26 hours. Imagine that. Yeah, like if what you do today, you get feedback tomorrow, or like the day after tomorrow. It's not a good thing to have. And releasing was a manual process which took me 1 hour. But I thought about it, and if your build cycle takes 26 hours and releasing manually takes 1 hour of my time, I should still think about fixing the build cycle first. Even if that means that I have to do the manual 1 hour task more often in the beginning, but I could also get a very good understanding of it and automate it in the next step. So what I did when we had this problem with the whole pipeline taking 26 hours is I had a look at the build log, and we used Jenkins back then. So there was a big console log, a lot of entries, and the first thing I saw is that not all the entries had timestamps. So I installed the timestamper plugin on Jenkins. So this problem was solved. So I saw which step took how long, and I did some math. I was new to the project, so I didn't really know a lot of details about it, but at least I saw from the timestamps which were the culprits. I also found that the build was disk bound, so we had an I/O problem. And I was lucky. There was like a very small SSD in the build PC, which I used to run an experiment. So I moved one of the jobs from the hard disk to the SSD. And what I saw is an immediate improvement of 36%. So I went to my manager and said, that's the cheapest 200 to 300 whatever euro you can invest to speed up something by 36%. And of course we did it. What I also mentioned before is when things deteriorate a lot is when you're in an overload situation, there's a tendency to do more planning. But I think it's better to accept the uncertainty and appreciate the flexibility of a software project. So there's a decreasing marginal utility of each hour spent planning. Some authors even said that every hour you spend planning is an hour not delivering, as the resources overlap. I think you should come up with a lightweight capacity planning approach, or even do it just in time. So some people just list the features and the rough numbers of for the estimates for each initiative. Then they have a cutoff and just do the detailed analysis on a just-in-time basis. For example, prioritizing by cost of delay. So maybe you find out that you do not need one of these initiatives because there's no big benefit to it. What's also important is that there should be only one most important thing, and let people know so that there are no conflicting priorities. So less is more, and this is also something that you should take into account when looking at your work items. So you should really reduce your work in progress and batch size. So stop starting and start finishing. For example, all the agile approaches have this more or less built in. So for example, in Kanban, you have work in progress limits. In Scrum, you have the sprint scope, so you have the work in progress limited in kind of a way. This also decreases context switching. It increases your focus. It potentially reduces your cycle time, and you get faster feedback. And usually, quality takes some time. So if you have a quality problem, maybe you should reduce quantity to increase quality. You should also try to say no to additional work, or at least postpone it. So you also want to reduce variability and increase predictability. For example, reduce the number of platforms you build your project on, kill zombie projects that are highly unpredictable. Try to work on less versions and, for example, using trunk-based development, and fix the root cause. You should also do less. We already heard this today that some studies say that 50 to 2/3 of all features are never used or not really used. So do less new and unique work. For triage work, you could apply automation and work in smaller batches to make sure that you have fewer changes that you need to investigate if something goes wrong. And what I also wanted to say is you could, for example, build a self-service platform where your development team can deploy on their own. So in my last company, we set up a CI/CD platform using Jenkins, and if you automate everything, you come to the point where it doesn't really make a difference, at least on the happy path, who presses the button to release your software. So it changed from a matter of having time to and the necessary skill to a matter of permission. So automate, but first try to eliminate. So, and that's something that we heard in the keynote today, automate everything. And I have to say that I am opposed to that. No, we should not automate all the things. We should make time to create automation, but really check what we should automate. And the first thing you will do is eliminate. So documenting the process and making it repeatable is the first step to automation. Yeah, I already said that. Yeah, fix the biggest bottleneck first. So everything else could make things worse and accumulate backlog. What's also interesting is that it may not even be a technical problem. For example, you just have to find the right person, or the persons are overloaded. There are different approaches to automation. For example, there's the leftover principle, which says automate everything, and the things that are left are then done by humans. And there are some unrealistic assumptions of that, but still it's a nice framework to think about. So the easy and the rare stuff you can do manually. The easy and frequent stuff you try to automate. You first start to eliminate everything that's not part of your value proposition, or does not contribute to your value proposition. The frequent and difficult stuff you should try whether there is, for example, an open source solution or a commercial solution that you can acquire. And for the rare and difficult stuff, try to create tools, document, and for the very rare and very difficult solution, maybe get a consultant or hire someone to do it. There are also other approaches, but it's important to note that automation is not a silver bullet solution. And there's also a word of caution necessary. So this is also taken from the 2018 DevOps report. And what they say, there's the paradox of automation, and they draw this J-curve. So you begin with your transformation, everything looks perfect, and you automate your build, for example, and everything. But what you then find is that the tasks that you still have to do after the automation is in place are harder. So when the new automation is in place, there is less total work to be done by humans, but what is left is harder. And so you really need to have this spare capacity and invest to reach this elite group of performance. So for example, if you use Fastlane to deploy iOS app and it fails, then it takes, at least me, takes a day to understand how signing iOS apps works again, because it abstracts everything away. And once it does not work, if Docker doesn't work, then have fun analyzing it. So we freed ourselves from Quicksand, which is, as described, a vicious circle. It pulls you in the harder you try to resist. And if you're not constantly working to improve, then by default, you're gradually getting worse. It's like the second law of thermodynamics. Entropy just increases. But what's next? What we want to establish is actually a virtuous circle, which is defined as a recurring cycle of events, the result of each one being to increase the beneficial effect of the next. So we need to establish a culture of learning and improvement that compound. For example, Jess Humble, the author of Continuous Delivery, says that lean works by investing in removing waste so that you can increase throughput. Prioritize improvements that will do the most to improve flow. So you start with the bottleneck, your biggest source of waste, fix it, and then identify the next bottleneck. Yeah, they also discuss this in the Accelerate book, that improving your software delivery effectiveness will improve your ability to work in small batches, and lean product management practices positively impact software delivery, so it's like a virtuous circle. So one improves the other. But this may be a complex problem, so you may not really know where to start, just that what you want to achieve. So one experimental approach for product development and also for process improvement is the improvement cutter. So you set out the direction, you grasp the current condition, you just don't know how to get there, but you know what you want to achieve. For example, I don't know, deploy once per day, and then you conduct experiments. And so you try to establish the next target condition and learn a lot of stuff in between and try to reach this this end goal, or then the next one. Another tool which can help is to collect improvement ideas and prioritize them. And this may seem obvious, that you should start with the easy, high impact changes. But what I see is that there are companies, and it also happens in my company or in my team, that are still waiting for the hard, high impact rewrite of your software, or like the new, let's not invest into the build pipeline. We are changing systems anyway in a year. But it hurts every day, so you really should think about it. So again, we want to achieve this virtuous circle where you have more releases and test automation improvements. This leads to faster releases, more time for new work, more frequent releases, smaller batches, less work in progress, fewer changes per release, fewer bugs per release, faster feedback, and faster. It's all about faster feedback, higher confidence, lower variability and rework, more time, and so it goes round and round. So taking this into account, we went on a journey of roughly 6 months to a year. We really spent 20% or roughly 1 day a week to improve something. I have to admit it was not always the bottleneck that we fixed, but in each and every case, at least the bottleneck got more obvious. We also created a self-service pipeline, reducing stress and our own workload. We used information radiators to inform others about on what we were working on, reducing interruptions, and we set clear priorities and weekly goals and followed up on them. So rather than hiring more people, at least in this case, the crisis really allowed us to transform the way that we've been working, reaching a state where every one of us had like 20% headspace and work on improvement stuff 1 day a week. So we did way more with way less, being more effective, efficient, and satisfied at the same time. So I want to conclude with a recap of the things we talked about today. So first thing first, this is my experience, and as this is a complex or at least a complicated problem, your mileage will most likely vary. Crisis situations are opportunities for change. Never waste a good crisis. Often it takes fresh eyes or at least courage to see the problems. Yeah, get out of the quicksand. The sky is the limit. quantify the work and set goals, measure, less is more, automate the right things, establish a continuous improvement process, and try to start a virtuous circle. And this is also in line with the 3 ways of DevOps, which say that the first way is talking about the workflow, the second way is improve feedback, and the third way is continual experimentation and learning. But also don't forget that it's people over process over tools, so it's not always a technical issue. If you want to know more, you should really read these books. I read all of them, and they are very, very good. If you don't have time, then watch the talks of the authors on YouTube. And I want to close with a quote from Dominica de Grande's book, Making Work Visible. It also was on the previous list. We don't let our servers get to 100% capacity utilization, so let's not do that to ourselves. I have some more references in my slide that will be available, and I'll put them online. And thank you for your attention. Don't wait, get in touch.